All right, this screencast is going to help you take percent compositions and change them into a chemical formula using either empirical or molecular formulas. An empirical formula is the lowest whole number ratio of the atoms in the or elements in the compound. So in this case, BH3 can't be reduced any further, and it is a empirical formula. A molecular formula is the multiple of an empirical, and it can be the same, but it's usually multiples, so B2H6. There are several steps in doing the process and solving the problem here for finding an empirical formula. You first convert the percent into grams, and then you take the grams and change it to moles using the molar mass. You're going to divide each of the moles amounts by the smallest one to get either a whole number or something closer to a half. Then you're going to make a whole number ratio and write it as a formula. So let's try this problem with those steps, and I'll talk you through it. So you have a problem of 80% carbon and 20% hydrogen, and you want to know the formula. We're going to assume that we have a 100-gram sample, which would mean that we have 80 grams of carbon and 20 grams of hydrogen, and we're going to convert that into moles using the molar mass, and it looks like this. So we have 80 grams of carbon, and converted would be 6.67 moles of carbon, and then we would have also 20 moles of hydrogen. So now our next step is to divide by the smallest whole number of moles. And so we're going to divide both terms by the 6.67 moles, and we get 1 for the carbon and 2.99 for hydrogen. Now, the only place that you should round would be here at the very end. It is better in the middle step when you're finding the number of moles to carry 2 or 3 decimals, because if you round too early, you will get your ratios won't be accurate. So in this case, we can see that we have essentially whole numbers, and our formulas have to have whole numbers. So our answer would be C1H3 or CH3. Okay, so here's another example. We have the empirical find the empirical formula for a compound with 25.9% nitrogen and 74.1% oxygen. Again, total sample of 100. We're going to convert our grams into moles, and we have 1.85 moles of N and 4.63 moles of O. Again, keep 2 or 3 decimals at this point. You don't want to round too early. So we are going to now divide by our smallest number of moles, and that would give us an N value of 1 and an O value of 2.5. 2.5 is not a whole number, so this is not finished. We cannot just say it's NO3 because that's not a very accurate representation of those percentages. What we can do is we can multiply all the terms by a whole number to make another end whole number. So what's the lowest common multiple that we could get, or what can we multiply by to get a whole number in the case of the 2.5? And if we multiply everything by 2, we would get N2O5. So our empirical formula here would be N2O5, and you can see that whenever you have to multiply, you want to multiply by the smallest number possible. You wouldn't want to multiply by 10 and get N10O25. We would want to have it a lower ratio. All right, so the next step is finding the molecular formula from the empirical formula. So once you find the empirical formula, they can add another layer of more work to the process. So in finding the molecular formula, remember the molecular is a multiple of the empirical. So sometimes when they give you a molecular problem, you first have to find the empirical formula. So here is the additional piece. You determine the molar mass of the empirical formula, divide the molar mass by the empirical formula molar mass, and then you will find the multiplier term. So what does that look like? Well, here is a problem. It says, what is the molecular formula of a compound with a molar mass of 60 grams per mole and an empirical formula of CH4N? So they're being nice. They're giving you the empirical formula, and now all you have to do is add the additional piece to it. So what you do is you find the molar mass of the empirical formula they've given you by taking the fact that there's 1 carbon, 4 hydrogens, and 1 nitrogen, multiply them by their molar masses, and get the formula mass for the whole thing. So this is 30 grams. We'll then take that 30 grams and divide it by the 60, or I'm sorry, take the 60 that they gave us, and we'll divide that 30 into the 60 to tell me that I need to multiply my empirical formula by 2. So my molecular formula for this particular substance is C2H8N2. Okay, so there's one more additional piece that we could make this the biggest problem, which would combine both finding the empirical and the molecular. So this compound says, or this example says, the compound has 50.7% carbon, 4.2% hydrogen, and 45.1% oxygen, and it says what its molar mass is 142, and what is the formula. So the first step we have to do is find the empirical formula. So we're going to take our percentages there and find the number of moles. And then the next step would be to divide by the smallest number, which is the 2.819. And we would get a ratio of 1.5, 1.5, and 1. Since they are not whole numbers and not close enough to be rounded, we're going to multiply them all by 2, and we get 3, 3, and 2. So our empirical formula is going to be C3H3O2. So we have to find the mass of that empirical formula so that we can use it to find the molecular formula. So we're going to add up the mass, and that is 71 grams. And we will take the 142 that they gave us in the problem, and we will divide it by our 71, and that tells me that the multiplier is 2. So my molecular formula is C6H6O4. Okay, go back and look at that again if you've missed a step, or if you just need to figure out the actual order.